So now we're going to move on to absolute value inequalities, which is basically everything we've already done with absolute value equations, but put together with the rules we know about inequalities. So instead of absolute value equations becoming a compound equation, two equations, absolute value inequalities are going to become compound inequalities. And the way that I remember this is when the variable or the absolute value is less than, it's going to become an and inequality. So right here I have the absolute value of 2x is less than 18. That's going to become an and less than inequality. Absolute value is less than or equal to 12. Absolute value is less than 20. Because the absolute value is less on every single one of these, I know my inequality is going to become an and inequality. So remember with absolute value, if I take the absolute value of a number, inside those absolute value bars, I can take the absolute value of a positive number, or I can take the absolute value of a negative number. So inside these absolute value bars, if I want the absolute value to get 18, I can take the absolute value of 18 and get 18. But I could also take the absolute value of negative 18, and I would still get 18. So inside these absolute value bars, they have that 2x, and that 2x, instead of being equals, in this case it's an inequality, we're going to put that less than. But on the other side, we're going to put negative 18. And remember, if I cover up what's in the middle, this should actually be true. Negative 18 is less than a positive 18. So now, this is just solving a compound inequality. If I need to get rid of this multiply 2, I have to divide 2, but what I do to one side, I have to do to all the sides. My best friend is positive, so my inequality signs are going to stay the same. Negative 18 divided by 2 is negative 9. In the middle, I still have that x, and over here I have a positive 9. So I would read this as negative 9 is less than x, which is less than positive 9. And remember, if I cover up what's in the middle, this should still be true. So to graph this, I would need to go from negative 9 to positive 9. But remember, we want to go one further to either side. So I actually want to start at negative 10 and end at positive 10. So negative 10, negative 9, negative 8. There's a lot of numbers in between. So I'm going to go ahead and just put the dot, dot, dot. Then I'm going to pick back up at positive 8, positive 9, and positive 10. So I put my circles on negative 9 and positive 9. And since they can't equal, then I'm not going to fill in those circles. But if I cover this up, remember if it's true, it means I shade everywhere in between. So it means x should be able to equal negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, all those numbers in between negative 9 and 9. So to check, you should be able to plug in any of those numbers in that shaded area. I'm going to choose 0. Is 0 on the number line right there? Well, in between negative 8 and 8, I would have 0. So in that original problem, the absolute value of 2x is less than 18. Instead of x, I'm going to erase x, and I'm going to pick 0 because that's in my shaded area on my graph. Well, 2 times 0 is 0, and the absolute value of 0 is still 0. And is 0 less than 18? It actually is. So that means this is true. So let's move on to this one. The absolute value of 3x plus 6 is less than or equal to 12. Remember, that means everything inside these absolute value bars can be a positive or a negative 12. So I have 3x plus 6 is less than or equal to 12. And on the other side, I'm going to go ahead and put the negative 12. Well, this is the same exact concept as we did before, but now instead of just a one-step, we're moving on to a two-step. Well, 3 and x are best friends, so they're going to stay together. So we have to get rid of that plus 6. To get rid of a plus 6, we have to minus 6. And what we do to one side, we have to do to all the sides. So over here is same sign, add and keep. I get negative 18. This 6 minus 6 cancels out, and I have a positive 3x. And 12 minus 6 is 6. Remember, if I cover up what's in the middle, it should still be true. Negative 18 is less than a 6. So now let's finish the problem. I still have that 3 multiplying x, so I have to divide by 3 to get rid of it. So negative 18 divided by 3 is negative 6, which is less than or equal to that x, which is less than or equal to 2. So basically what this is saying is x can be any number in between, because it's in the middle, in between negative 6 and a positive 2. So if I were to graph this solution, I would need negative 6 to a positive 2. But remember, we need 1 on either side, so I'd start at negative 7, and I would end at 3. So negative 7, negative 6, negative 5, negative 4. I'm going to put a dot, dot, dot to show that there are numbers in between. And I'm going to pick back up at 0, 1, 2, 3. So I'm going to put my circles on 2 and negative 6. And what do those lines underneath mean again? Oh, right. They mean that it can equal. So x can equal negative 6 or x can equal a positive 2. So I'm going to go ahead and color in those circles. We're going to have closed circles on negative 6 and a closed circle on a positive 2. And remember, if I cover up what's in the middle, negative 6 is less than 2. If this inequality is true, then we shade everything in between. So x can equal negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, and 2. If I plugged in any of those numbers back into my inequality, it should make this true. So the last inequality over here, everything in this absolute value bars, remember, should be able to equal a positive or a negative 20. Most common mistake that people make is they just make everything inside the absolute value bars a positive. But remember, absolute value is going to equal a positive number, but inside the absolute value bars, we can have positives or negatives. So we don't change what's inside the absolute value bars. We just know what's inside those absolute value bars can equal a positive 20, or I could also take the absolute value of negative 20 and it would still become 20. So inside those absolute value bars, they have negative 5x plus 10. And I know in those absolute value bars, it can be a positive 20 or it can be a negative 20. And remember, if I cover up what's in that inequality sign, it should still be true. Negative 20 is less than a positive 20. The trick to this one, the best friend is negative. And remember, what do we have to do if we have a negative best friend? We have to flip those inequality signs. So I'm going to flip those inequality signs before I do anything else so that I don't forget in that final step. So I'm going to keep that negative 5 and the x together, so I need to get rid of this plus 10. And to get rid of a plus 10, I have to subtract 10. So over here, same sign, add and keep, I get a negative 30 is less than or equal to, in the middle I still have a negative 5x. I know some of you think it's silly to circle the best friend, but when I circle this negative and the 5 together, I don't forget to bring down the negative. So that's why I tell you guys to go ahead and circle that best friend, because now that negative really stands out so I don't forget to bring that down to the next step. Then I have less than or equal to, and 20 minus 10 is 10. But remember, I'm not finished yet because negative 5 is still multiplying the x. And how do we get rid of multiply? Our final step is divide. Remember, if I just divided by 5, only the 5 would cancel out. But I don't just want the 5 to cancel out, I also need the negative to cancel out as well. So since I divided all sides by a negative, that's why my inequality signs flip. Over here, the two negatives cancel out, and this actually becomes a positive 6 is greater than or equal to x, which is greater than or equal to 10 divided by negative 5. This becomes a negative 2. So I know it seems a little backwards because the positive number is on the left. But if I cover this up, this is saying 6 is greater than negative 2, which is actually true. So we can go ahead and graph our solution. Negative 2 is the smaller number, so I'm going to put that on the left. But remember, I need to start one further, so I'm going to say negative 3, negative 2, negative 1, 0. I'm going to put the dot, 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 and pick up at 4, 5, 6, and remember I need to go one further, so go to 7. I'm going to have circles on the negative 2 and the positive 6. Since I have the lines underneath, those circles are going to be closed circles, so we're going to color those in. Since the x is in the middle and this inequality is true, that means all the numbers in the middle of these two numbers should work. So x should be any number in between negative 2 and positive 6. Remember, if you're not sure, pick any number in between and plug it back in and it should still work. So if I plugged in 0 back up into this original problem, negative 5 times 0 is 0, and 0 plus 10 makes 10. Well, the absolute value of 10 is still just 10, and yes, 10 is less than 20. So all of these numbers in between should make that inequality true.